Hi, good morning students. In last session we discussed about Ohm's law and also some of the examples on resistivity. So in this session is a very important session because we are going to derive two very important expressions. These two expression, one expression derivation of one expression should be comes to your final examination. So you have to concentrate on these expressions, okay? And also one of the problems will be come from these two expression. So now I am going to consider the first expression, that is the expression for equivalent resistance of the three resistors when they are connected in series. Another one is the equivalent resistance of three resistors when they are connected in parallel. So these are the two expressions. Derivations are comes under the chapter of electricity. These two derivations are very important. You have to concentrate, you have to practice more on this. See, listen here. Consider three resistors. Consider three resistors R1, R2, R3. Consider three resistors of resistance R1, R2, R3. They are connected in series as shown in figure. So when you are going to derive this expression, simultaneously we have to draw the circuit diagram because it is very easy to write the procedure how we are going to derive the expression. That is, consider the three resistors R1, R2, R3 in such a manner that they are connected in series. See, what is the series connection here? Series connection is nothing but end-to-end connection. Series connection means end-to-end connection. That is, these are the resistors of a resistance R1, R2 and R3. Yes, let I be the total current flowing through the circuit. Consider three resistors of resistance R1, R2, R3. They are connected in series as shown in figure, and let I be the total current flowing through the circuit. Let I be the total current. I represents the total current, and the connection of series resistor becomes that is end-to-end connection. End-to-end connection, it is nothing but series connection. And let V1, V2, V3. Let V1, V2 and V3 are the potential difference across the three resistors R1, R2 and R3 respectively. Here it is. V1, V2, V3 are the potential differences across the three resistors R1, R2 and R3. From Ohm's law, from Ohm's law, the potential difference across across R1 is that is V1 is equal to IR1, because from the Ohm's law we know that Ohm's law states, according to the Ohm's law, the potential difference in the resistors R1 is equal to V1 is equal to IR1. Similarly, the potential difference across the resistor R2 is potential difference across the resistor R2, that is V2 is equal to IR2. Next, similarly, the potential difference across the resistor R3 is equal to that is V3 is equal to IR3. See, the potential from the Ohm's law, potential difference across the resistor R1 is V1 is equal to I into R1, because the total current passing through the circuit is I only. Then the potential difference across the resistor R2, that is V2 is equal to IR2. And again same in the similar manner, the potential difference across the resistors R3 is V3 is equal to IR3. But the total potential difference across the circuit, across the circuit V is equal to V1 plus V2 plus V3, because here three potential difference, because we have here three resistors we have, so here three potential difference we have, so total potential difference across this resistor is nothing but the sum of all the potential differences across the three resistors, that is V1, V2 and V3. Therefore, substituting the values of V1, V2 and V3 here, V is equal to IR1 plus IR2 plus IR3. It implies as V is equal to, here I is common factor, take it outside, I into R1 plus R2 plus R3. Take it as the equation number 1. Carefully listen here, we are considering here the three resistors R1, R2, R3. If we are going to replace these three resistors by an equivalent resistance, okay, by an equivalent resistance we are replacing three resistors into one resistor, that is, if the resistors are replaced by equivalent resistance RS, then the potential difference across the resistor is See here how we are going to replace the three resistors. This is the equivalent resistance. We are going to replace this is the equivalent resistance. So if three resistors are replaced by this equivalent resistance Rs, then the potential difference across the resistor V is equal to IRS. Take it as second one. From equation number 1 and 2, it is clear that from equation number 1 and 2, here equation 1 says V is equal to I into the bracket R1 plus R2 plus R3. Here from equation number 2, V, the potential difference V is equal to I into Rs. That is IRS is equal to I into R1 plus R2 plus R3. Here I is the common factor that will be get cancelled. Rs is equal to R1 plus R2 plus R3. This is the required expression for the equivalent resistance of a three resistors when they are connected in series. So when we are going to, here is we get only three resistors. If we are going to consider in the circuit n number of resistors, then the equivalent resistance of then n number resistors is nothing but Rs is equal to R1 plus R2 plus R3 plus so on up to Rn. So it is nothing but the expression for the equivalent resistance of resistors when they are connected in series. You have to concentrate more on this derivation because it is one of the most important questions, will come for 4 marks to your examination. Either may series resistors are given or may parallel resistors are given. So and also one of the problem will be comes on these two expressions. So you have to carefully look at the derivation. Once again I am expressing here. First you should try to draw the diagram, try to remember the diagram. Once you are going to draw the circuit diagram perfectly, you are going to derive the expression very easily. See, listen here. First one is, what is the first step? Consider the three resistors of resistance R1, R2, R3. They are connected in series. They are connected in series. Let I be the total current flowing through the circuit. Let I be the total current flowing through the circuit. Let V1, V2, V3 are the potential difference across the resistors R1, R2 and R3 respectively. From Ohm's law, the potential difference across the resistor R1 is equal to V1 is equal, that is V1 is equal to IR1. Similarly, the potential difference across the R2, that is V2 is equal to IR2. Similarly, the potential difference across the resistors R3 is equal, that is V3 is equal to IR3. So, but the total potential difference across the three, this circuit diagram is nothing but V, that is the total potential difference across the circuit. V is equal to V1 plus V2 plus V3, that is V is equal to, substituting the values of V1, V2 and V3 here, that is V is equal to IR1 plus IR2 plus IR3. So here I is the common factor, that is V is equal to I into the bracket R1 plus R2 plus R3, that is taken as a equation number 1. So now we are going to replace these three resistors by an equivalent resistance. What about the amount? What about the value of three resistors? That should be replaced by an equivalent resistance of Rs. Then what happens? If the resistors are replaced by an equivalent resistance Rs, then the potential difference across the circuit, that is V is equal to I into Rs, because again here the total current flowing through the circuit is nothing but I. So the potential difference across the circuit V is equal to IRS. Take it as a second equation. From the equation number 1 and the equation number 2, it is clear that is here V is equal to IRS, we get here V is equal to I into R1 plus R2 plus R3. From 1 and 2, IRS is equal to I into R1 plus R2 plus R3. Here is the current is the common factor in the both sides, that should be get cancelled. Then RS is equal to R1 plus R2 plus R3. That is the required expression for the equivalent resistance of the three resistors when they are connected in series. So it is very important derivation for your examination. So you have to clearly concentrate on this. Okay, next expression is expression for equivalent resistance of three resistors when they are connected in parallel. See, what is the difference between series connection and the parallel connection? Series connection, it is nothing but end to end connection, but is the parallel connection is, look at the circuit diagram. This is the circuit diagram, how we are going to represent the parallel circuits. See, these three resistors are parallel to one another. This is the parallel connection. In the last expression we studied, we draw the circuit of three resistors when they are connected in series, but here is the three resistors when they are connected in parallel. This is the voltmeter, R1, R2, R3. Here it is I1, I2, I3. What happens in the series connection? The potential difference across the resistor will be variable, but here in the parallel connection, the current flowing through the circuit, because the current coming from the battery towards the resistors will be divided here. So that is I1, I2, I3. That I1 is the current flowing through the resistor R1, I2 is the current flowing through the resistor R2, I3 is the current flowing through the resistor R3. V be the total potential difference. V be the total potential difference across the resistors R1, R2 and R3. See, write down here. Consider three resistors. Are of resistance R1, R2, R3 such that R1, R2, R3 in figure, such that as shown in figure, such that they are in series. They are in parallel. They are connected in parallel. Let V be the total potential difference let V be the total potential difference across the circuit. Across the circuit. Let I1, I2 and I3 be the current flowing through the resistors, R1, R2 and R3 respectively. See, once again, consider three resistors R1, R2, R3. They were such that they are connected in parallel to each other. Let V be the total potential difference across the three resistors, and I1 is the current flowing through the resistor R1, I2 is the current flowing through the resistor R2, I3 is the current flowing through the resistor R3. So now from Ohm's law, the current flowing through the circuit from Ohm's law, current flowing through the circuit, current flowing through the resistor R1 is current flowing through the circuit, current flowing through the resistor R1 is I1 is equal to V by R1. I1 is equal to V. It is the total potential difference across the circuit, and R1 is the resistance. I1 is equal to V by R1. Similarly, the current flowing through the resistor, current flowing through the resistor R2 is that is I2 is equal to VR2, V by R2. Similarly, the current flowing through the resistor, R3 is I3 is equal to V by R3, V divided by R3. See carefully, from the Ohm's law, current flowing through the resistor R1 is I1 is equal to V divided by R1. Similarly, the current flowing through the resistor R2 is I2 is equal to V divided by R2. Similarly, the current flowing through the resistor R3 is I3 is equal to V divided by R3. Here V is the total potential difference across the circuit. But the total current flowing through the circuit, the total current flowing through the circuit is I is equal to I1 plus I2 plus I3. I is the total current I is the total current flowing through the circuit, that is I is equal to I1 plus I2 plus I3. Substitute the values of I1, I2 and I3 here. That is I1 it is V divided by R1 plus V divided by R2 plus V divided by R3, that is I is equal to, it implies us I is equal to, V is the total common factor here, take it outside, V into 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Take it as equation number 1. If the three resistors are replaced by an equivalent resistance Rp, if the three resistors are replaced by equivalent resistance Rp means are parallel, then the total current flowing through the circuit is, if the three resistors are replaced by equivalent resistance Rp, then the total current flowing through the circuit, that is I is equal to V divided by Rp. Take it as equation number 2. Comparing the equation number 1 and 2, or from equation number 1 and 2. From equation number 1 and 2. Here, what is the equation number 1? I is equal to V into the bracket 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Here, equation number 2 represents I is equal to V divided by Rp. From 1 and 2, V divided by Rp is equal to V into the bracket 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So here V is the common factor and that can be get cancelled. It implies us 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. This is the required expression for the three resistors when they are connected in parallel. This is the required expression for the equivalent resistance of three resistors when they are connected in parallel. Once again, look here. Consider the three resistors R1, R2, R3 in such a manner that they are in parallel to each other. Let V be the potential difference across the circuit and I1, I2, I3 be the currents flowing through the resistors R1, R2, R3 respectively. From Ohm's law, current flowing through the resistor R1 is I1 is equal to V divided by R1. Again, similarly, the current flowing through the resistor R2 is I2 is equal to V divided by R2. Similarly, the current flowing through the resistor R3 is I3 is equal to V divided by R3. But the total current flowing through the circuit I is equal to I1 plus I2 plus I3. So now we are going to substitute the values of I1 plus I2 plus I3, that is I1, I2, I3 in here. That is the value of I1 is V divided by R1, value of I2 is V divided by R2, value of I3 is V divided by R3. That is I is equal to V divided by R1 plus V divided by R2 plus V divided by R3. It implies us I is equal to, here V is the common factor, take it outside, that is I is equal to V into 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Take it as the equation number 1. If the three resistors are replaced by equivalent resistance Rp, then the total current flowing through the circuit I is equal to V divided by Rp. Rp represents the equivalent resistance of three resistors when they are connected in parallel. So comparing the equation number 1 and 2, we get that V divided by Rp is equal to V into 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Here V is the common factor in the both sides, that can be get cancelled, that is we get 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. This is the required expression for equivalent resistance of the three resistors when they are connected in parallel. If the n number of the resistors are connected in parallel in a circuit diagram, then the expression for the equivalent resistance of the n number of resistors when they are connected in parallel is nothing but 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 plus so on up to 1 divided by Rn. See, this is the expression, very important expression for the equivalent resistance of the resistors when they are connected in parallel. These two derivations are very important for your examination, that can be asked for 4 marks question. Either the series connection will be asked or the parallel connection will be asked. In these two expressions, one question should be there to your examination. Please be concentrate on these two expressions. Okay. Next, in the next session, we are going to discuss some more problems on these two expressions. Thank you.